The Atlantic Meridional Overturning Circulation, or AMOC, is a vital system of ocean currents. It acts like a giant conveyor belt, transporting warm water from the tropics northward. This warm water helps to regulate the Earth's climate. Without the AMOC, much of the northern hemisphere would be significantly colder. It plays a crucial role in maintaining the temperate climates we experience in regions like Europe and North America. The AMOC is driven by differences in water density. Warm, salty water in the tropics is less dense and flows northward along the surface. As it cools in the North Atlantic, it becomes denser and sinks to the depths. This sinking water then flows southward, completing the circulation. The AMOC is a complex system that is vital to the Earth's climate. Recent studies have raised significant concerns about the stability of the Atlantic Meridional Overturning Circulation, or AMOC. This crucial ocean current system plays a vital role in regulating the Earth's climate by redistributing heat and influencing weather patterns. Scientists at the University of Gothenburg and the Alfred Wegener Institute have been meticulously studying the effects of melting Arctic ice on the AMOC. Their research is shedding light on how these changes could have far-reaching impacts on global climate systems. Their findings suggest that the increasing influx of freshwater from melting glaciers and ice sheets is disrupting the delicate balance of the AMOC. This influx of freshwater dilutes the salinity of the ocean, which is a critical factor in driving the circulation of these currents. The Beaufort Gyre, a large system of swirling currents in the Arctic Ocean, plays a crucial role in this process. This gyre acts as a reservoir, collecting and storing fresh water from various sources. The gyre collects fresh water from melting ice and river runoff. This accumulation of fresh water is a natural part of the Arctic's hydrological cycle, but it is now being influenced by the accelerated melting of ice due to rising global temperatures. Normally, this fresh water is gradually released into the North Atlantic, where it mixes with the saltier water. This mixing process is essential for maintaining the density-driven circulation of the AMOC. However, the increasing rate of Arctic ice melt is putting a significant strain on this system. The rapid addition of freshwater is altering the salinity balance more quickly than the system can adapt. The weakening of the Beaufort Gyre is a cause for concern. As the gyre's ability to retain freshwater diminishes, the stability of the entire Arctic Ocean circulation is threatened. As the gyre weakens, it becomes less able to hold on to the vast amounts of freshwater it has accumulated. This could lead to an imbalance in the distribution of freshwater and saltwater in the region. This could lead to a sudden and massive release of freshwater into the North Atlantic, disrupting the AMOC. Such a disruption could have profound effects on global climate patterns, potentially leading to more extreme weather events and shifts in climate zones. The potential consequences of a massive freshwater release from the Beaufort Gyre are significant. The influx of freshwater into the North Atlantic would reduce the salinity of the surface waters. This would make them less dense and less likely to sink. This disruption to the sinking process could weaken or even halt the AMOC, with potentially catastrophic consequences for the global climate. The AMOC is a delicate system that is sensitive to changes in salinity and temperature. The influx of freshwater from melting ice and the weakening of the Beaufort Gyre are pushing this system closer to a tipping point. The consequences of crossing this threshold could be severe. The potential collapse of the Atlantic Meridional Overturning Circulation, or AMOC, is a scenario that has been explored in popular culture, most notably in the film The Day After Tomorrow. This film, while a work of fiction, brings to light the dramatic and far-reaching impacts that such an event could have on our planet. While the film takes dramatic license with the science, it highlights the potential for rapid and catastrophic climate change. The melting of polar ice caps and the resulting influx of freshwater into the ocean could disrupt the delicate balance of ocean currents. In reality, the consequences of an AMOC collapse would likely be less abrupt, but no less severe. Scientists are diligently studying these ocean currents to understand the potential impacts better. Satellite images and advanced modeling techniques are helping to predict how changes in the AMOC could unfold. Europe, particularly northwestern Europe, would experience much colder winters. The warm currents that currently moderate the climate in this region would weaken, leading to harsher and longer winters. Sea levels along the eastern coast of North America could rise significantly. This rise in sea levels would exacerbate the risk of flooding in coastal cities. threatening homes, businesses, and critical infrastructure. Storm tracks could shift, leading to more frequent and intense storms in certain regions. The redistribution of heat in the ocean could alter weather patterns, making some areas more prone to hurricanes and other severe weather events. The collapse of the AMOC would have far-reaching consequences for agriculture, infrastructure, and human societies. Farmlands could be devastated by flooding, and the increased frequency of storms could destroy infrastructure, leading to economic and social challenges. It is a stark reminder of the interconnectedness of the Earth's systems and the potential for human activities to disrupt them. The AMOC is just one part of a complex global system, and its collapse would have ripple effects across the planet, affecting ecosystems, weather patterns, and human livelihoods. While the complete collapse of the Atlantic Meridional Overturning Circulation, or AMOC, is still considered a low-probability event, there is growing evidence that it is weakening. This evidence comes from a variety of sources, including satellite data, ocean buoys, and historical records. Studies have shown that the AMOC is currently at its weakest point in over 1,000 years. This is a significant finding, as the AMOC plays a crucial role in regulating the climate of the North Atlantic region. This weakening is consistent with what climate models predict should be happening due to human-caused climate change. The increase in greenhouse gases in the atmosphere is leading to higher global temperatures, which in turn affects ocean currents. Scientists have observed a slowdown in the circulation of the AMOC. This slowdown has been linked to changes in the temperature and salinity of the ocean, which are critical factors in the functioning of the AMOC. They have also detected changes in the temperature and salinity of the North Atlantic that are consistent with a weakening of the current. These changes are not just theoretical. They have been measured and documented by researchers. These observations provide further evidence that the AMOC is being affected by climate change. The implications of a weakened AMOC are profound, potentially leading to more extreme weather events and disruptions in marine ecosystems. The evidence is clear. The AMOC is weakening, and this trend is likely to continue if current levels of greenhouse gas emissions persist. Human activities, such as the burning of fossil fuels, deforestation, and industrial pollution, are the primary drivers of this change. These activities release large amounts of carbon dioxide and other greenhouse gases into the atmosphere, which contribute to global warming. This should serve as a wake-up call to the urgent need to address climate change. It is imperative that we take immediate and sustained action to reduce greenhouse gas emissions and transition to renewable energy sources. The future of our planet depends on it. The potential consequences of an AMOC collapse are too great to ignore. Reducing greenhouse gas emissions is essential to mitigate the risks posed by climate change, including the potential collapse of the AMOC. The international community must work together to transition away from fossil fuels and towards renewable energy sources. We must invest in energy efficiency, sustainable transportation, and responsible land use practices. Every effort must be made to limit global warming and prevent the worst-case scenarios of climate change. The time for action is now. The longer we wait, the greater the risks we face. We have a moral obligation to future generations to act decisively to address this global challenge. Addressing climate change requires a global effort. Developed nations, which have historically contributed the most to greenhouse gas emissions, have a particular responsibility to lead the way in reducing emissions and providing financial and technological support to developing nations. International agreements, such as the Paris Agreement, provide a framework for global cooperation on climate change. However, stronger commitments and more ambitious actions are needed to meet the scale of the challenge. Climate change is a global problem that requires a global solution. We must work together to create a more sustainable and equitable future for all. Even with aggressive action to reduce greenhouse gas emissions, some degree of climate change is already baked into the system. This means that in addition to mitigation, we must also invest in adaptation measures to cope with the impacts of climate change that are already being felt and those that are yet to come. Coastal communities will need to adapt to rising sea levels and more frequent and intense storms. Farmers will need to adapt to changing growing seasons and more extreme weather events. Cities will need to adapt to heat waves and increased risks of flooding. Adapting to a changing climate will require innovation, investment, and international cooperation. It is an essential component of our response to the challenges posed by climate change. The potential collapse of the AMOC is a stark reminder of the fragility of the Earth's systems and the potential consequences of human actions. It is a call to action to address the root causes of climate change and to build a more sustainable and resilient future. By reducing greenhouse gas emissions, investing in adaptation measures, and working together as a global community, we can mitigate the risks posed by climate change and safeguard our planet for future generations. The choices we make today will determine the future of our planet.